Let's do part A. So in part A, we show that the curve passes through the point pi by 2, comma, negative pi by 3. So it's basically we have to plug in x equal to pi by 2 and y equals negative pi by 3 into this implicit equation and ensure that it satisfies this equation. So let me do that. I plug in x equal to pi by 2. So it is sine of pi by 2 minus natural logarithm of 2 times of cos of y is negative pi by 3. So it is cosine of negative pi by 3. And on the right side, we have 2 times of sine of x plus y. That is pi by 2. Y is negative. So I put negative pi by 3. Let's evaluate this. Sine pi by 2 is value is 1 minus natural logarithm of 2 times of cos or the cosine of negative pi by 3. This is basically negative of cosine pi by 3. I'm sorry, it is basically cosine of pi by 3. It is not negative. You can just ignore this. In fact, I will just remove this and put it here. So it is 2 times of cosine of pi by 3. And this equals on the right side, we have 2 times of sine of pi by 2 minus pi by 3. Let's simplify this. Pi by 2 minus pi by 3. So here we have this common denominator as 6. In fact, we can do the multiplication like this. That is 3 times of pi is 3 pi and 2 times of pi is 2 pi. In between we had a negative. So I put a negative. So it is 3 pi minus 2 pi is pi and this is over 6. So it is a sine of pi over 6. Let's continue to verify. So here we have 1 minus natural logarithm of 2 times of cosine of pi by 3. Cosine of pi by 3 in terms of degrees, it is cosine of 60 degree and this equals 1 by 2. So I put 1 by 2 here and this equals 2 times of sine of pi by 6. Sine of pi by 6 in terms of degrees, it is I'm sorry, it is sine of, this is pi by 6 is sine of 30 degree and this also 1 by 2. So I put 1 by 2 here. Now we do the cancellation. 2 gets cancelled with 2 and so we will be left with 1 minus natural logarithm of 1 and this equals, we also see these two cancels, so we are left with 1. So we have 1 minus, we know that the natural logarithm of 1 is 0. So 1 minus 0 equal to 1. And this implies on the left side we had 1, on the right side we have 1. So this is true. And this means the point, that is a given point, passes through the curve. We now find the equation of the tangent line to the curve at this point. So to find the equation of any line, in fact, for the tangent line, we need two information. That is, we need a point as well as the slope of the curve at that point. We are already given the point, that is pi by 2 comma negative pi by 3, and we need to find the slope. We can find the slope by finding this expression, that is the derivative of y with respect to x at the given point. So this is basically the slope of the tangent line. So for that, I'm going to place this given curve in terms of implicit equation. So I'm going to find dy by dx by differentiating implicitly with respect to x. So first I differentiate this sin x. Differentiation of sin x is cosine x minus, here we have natural logarithm of 2 times of cosine of y. So here we have to apply the chain rule. That is, we have to consider the outer function as well as the inner function. The outer function is a natural logarithm function and the inner function is 2 cosine of y. So when we differentiate the outer function, that is natural logarithm of y, differentiation of any natural logarithm is 1 over the expression or inside the natural logarithm. So I'm going to put 1 over inside bracket. We have to put the inside part. The inside part is 2 cosine y. And then when you apply the chain rule, we have to multiply with the derivative of the inside function. That is the derivative of inside function, which is 2 times of cosine y. And this equals negative 2 sine y. And since we differentiate with respect to x, we will also have to differentiate y. So that is dy by dx. So this is basically equal to negative 2 sine y times of dy by dx. We close this with a bracket, and on the right side we will find the derivative. That is we have 2 times of sine of xy. So I put the constant 2 as it is, and derivative of sine function is a cosine function. So I put a cosine of x plus y. And once again, we have to apply the chain rule to find the derivative of this expression, x plus y. Let me put this inside a bracket. Derivative of x plus y with respect to x. Derivative of x is 1, and derivative of y is dy over dx. So basically, this expression is 1 plus dy over dx. Now let's simplify both the left and right side. Maybe I could just clear these things. Okay, so let's simplify this. We see that you can cancel this 2 as well as with 2, and we have a product of negative and negative, which is positive. So I'm going to rewrite this expression as cosine of x. Negative negative is positive, so I put positive. And then this expression sine y over cos y, we know that it is tangent of y times we have dy by dx, and this equals I'm going to distribute this complete expression 2 cosine x plus y into the brackets. We have two terms inside the brackets, so we will get the first expression 2 cosine of x plus y plus 2 cosine of x plus y, and then multiplied with dy by dx. Basically, we have to solve for dy by dx, which is our next goal. So let's do that. I'm going to group all the dy by dx onto the left side. So I'm going to put the dy by dx, which is on the left side as it is. And let me bring this dy by dx onto the left side. When I do that, I should put it as a negative term. So I already put a negative. So this is negative 2 cosine of x plus y. And this is part of dy by dx. So we put this as times dy by dx. And when we transpose this, here we will have this term 2 cosine x plus y. And when we transpose this term to the right side, we will get negative of cosine of x. Now let's factor the dy by dx from the two terms in the left side. So we will have, I can put this dy by dx in front, multiplied with, this is tangent of y minus 2 times of cosine of x plus y. And this equals, on the right side, we already have 2 cosine of x plus y minus of cosine of x. Now, since we have to solve for only for dy by dx, I'm going to divide both sides by this expression so that we get only dy by dx on the left side. So dy by dx, this equals, on the right side, we have 2 cosine of x plus y minus cosine of x. Then we have to divide by the expression, this expression, that is tangent of y minus 2 times of cosine of x plus y. So basically, this is the derivative expression, and the slope is the derivative at the given point, which means we have to plug in the point pi by 2 comma pi by 3. into the dy by dx. So let me do that. So we find dy by dx at the point pi by 2 comma negative pi by 3. So this gives the slope of the curve at this point. So let's do that. In place of x, we have to plug in pi by 2, and in place of y, we plug in pi by 3. So therefore, this becomes the cosine of pi by 2 minus pi by 3 minus cosine of x is pi by 2, and this is all over tangent of y, which is tangent of negative pi by 3 minus 2 cosine of x plus y. That is pi by 2 minus pi by 3. Let's calculate this. We already found that pi by 2 minus pi by 3. We can do the multiplication like this. So this is 3 pi minus 2 pi over 6. And this gives pi by 6. So I'm going to replace pi by 2 minus pi by 3 as pi by 6. Therefore, this becomes 2 cosine of pi by 6 minus cosine of pi by 2, and this is 0. Put 0 here, so I can just cancel it. So I do not have to put anything here. So it is divided by tangent of negative pi by 3 equals negative of tangent pi by 3. So this is according to the rule of trigonometry. That is, tangent of a negative angle is negative of the tangent of the angle. And once again, this is the same expression as this expression. So we can put this as 2 times of cosine of pi by 6. Let's evaluate this. Cosine of pi by 6 is basically cosine of 30 degree in terms of degrees. So this equals root 3 over 2. Uh, we could know about this from unit circle or from the standard trigonometric tables. So I'm going to replace cosine of pi by 6 as root 3 over 2, and this is all over negative of tangent of pi by 3 is tangent of 60 degree, and that equals root 3 minus 2 times of the same expressions, root 3 over 2. So let's calculate this. This equals, you see that we can cancel this 2 and 2, this 2 as well as this 2. So in the numerator we have root 3 over, this is negative root 3, and once again we have another negative root 3. So this equals root 3 over negative root 3 minus root 3. This is negative of 2 times of root 3. So basically this equals, these two will get cancelled, and we will get negative 1 by 2. So this is the slope of the curve at the given point, negative 1 by 2. Now that we found the slope of the curve at the point, we can find the equation of the tangent line using the point slope form of a line. So we utilize point slope form of a line, and that is y minus y1 equals m times of x minus x1, where m is the slope of the line. So I'm going to plug in x1, y1 as pi by 2, comma negative pi by 3. So plug in y1 equals negative pi by 3. So this becomes y minus of negative pi by 3. And this equals slope is negative half multiplied with x minus x1 is pi by 2. So let's simplify this. This equals y plus pi by 3 equals negative, I can distribute this negative half. So it becomes negative 1 by 2x plus negative times negative is positive. So it is pi by 4. And let me simplify the left side expression by multiplying and dividing the y by 3. So therefore this becomes 3y plus pi divided by 3, and this equals, even I can simplify these two terms by multiplying and dividing the first term by 2. So when I do that, I get negative 2x plus pi divided by 4. We now have the common denominator, that is the multiple of the denominator in the left as well as the right side expression, which is 12. So we multiply both sides by this common denominator to remove the fraction. So when we do that, we get 3y plus pi by 3 multiplied with 12, and this equals negative 2x plus pi divided by 4 multiplied by 12. We see that we can cancel this 12 with the 3 as 4 times, this 12 with 4 as 3 times. So it's basically we have to distribute this 4 into the terms, similarly distribute the 3 into the terms, and when you do that we get 12y plus 12 pi, and this equals 3 times negative 2 is negative 6x plus 3 times pi is 3 pi. So I'm going to have only x and y on one of the side. Therefore, I can put this as 6x. If I add a 6x, I get 6x plus 2y, that is 12y, and I subtract 12 pi. So I get 3 pi minus 12 pi, and this equals 6x plus 12y. This equals 6 minus 3 pi minus 12 pi is negative 9 pi. In fact, now I see that every term has a factor of 3. So I divide both the left and right side by 3. When I do that, I get 2x plus 6y. I'm sorry, I'm dividing by 3. So this will be 4y equals negative 3 pi. It looks like I did a certain mistake here. I just figured out that it's 4 pi, because 4 times pi is 4 pi and it is not 12 pi. So I'm changing this to 4 pi. So it will be 3 pi minus 4 pi. I'm going to remove all this here. This is p pi minus of 4 pi, and this equals negative pi. Can remove this. So this can be written in terms of y as well. That is, this implies, or we can say that this also the equation of the tangent line. In fact, we can consider this as the equation of a tangent line. If we want to write down this in terms of y, we write down this as 12y equals negative pi negative 6x, or in fact I can put this 6x in front. So I put this negative 6x. It is, if you want to write down this in terms of y equals mx plus p form, you can put negative 6x negative pi. Now I have to divide both sides by 12. So y equal to negative 6x divided by 12 minus pi by 12. So these two will get cancelled. That is, this goes 2 times. So it is basically, you can say that y equal to negative x over 2 minus pi by 12. So this is the equation of the tangent line.